Harvard professor finds fragments that could be of otherworldly origin, professor of science and the longest-serving chair of Harvard Astronomy Department, Abraham Loeb, nominee to the President's Council of Advisors on Science and Technology, known as PCAST. His claims are backed by U.S. Space Command, confirmed with almost near certainty, 99.999%, that the material is not of our home planet. Alien technology. Loeb in 2019 identified the meteor's interstellar origin in a paper he co-wrote with Harvard undergraduate student Amir Siraj. 3 years later, U.S. Space Command further confirmed in a 2022 letter to NASA that the object, deemed interstellar meteor, M1, came from another solar system. The $1.5 million expedition that Loeb led was to recover the fragments left over from the explosion on the floor of the Pacific Ocean at its crash site near Manus Island in Papua New Guinea. Between June 14 to 28, the crew searched over 108 miles of the ocean floor by combing it with a sled full of magnets attached to their boat. The crew brought the 50 spherules to the Harvard College Observatory for further study. The hunt for an interstellar meteor yields surprising findings. The government gave Loeb a 10 kilometers radius of where it may have landed. That is where the fireball took place, and the government detected it from the Department of Defense. It's a very big area, the size of Boston, so we wanted to pin it down, Loeb said. We figured the distance of the fireball, based off the time delay between the arrival of blast wave, the boom of explosion, and the light that arrived quickly. Their calculations allowed them to chart the potential path of the meteor. Those calculations happened to carve a path right through the same projected 10 kilometers range that came from the U.S. government. Loeb and his crew took a boat called the Silver Star out to the area. The ship took numerous passes along and around the meteor's projected path and combed the ocean floor. We found 10 spherules. These are almost perfect spheres, or metallic marbles. When you look at them through a microscope, they look very distinct from the background, Loeb explained. They have colors of gold, blue, brown, and some of them resemble a miniature of the Earth. An analysis of the composition showed that the spherules are made of 84% iron, 8% silicon, 4% magnesium, and 2% titanium, plus trace elements. They are sub-millimeter in size. The crew found 50 of them in total. It has material strength that is tougher than all space rock that were seen before, and catalogued by NASA, Loeb added. We calculated its speed outside the solar system. It was 60 kilometers per second, faster than 95% of all stars in the vicinity of the Sun. The fact that it was made of materials tougher than even iron meteorites, and moving faster than 95% of all stars in the vicinity of the Sun, suggested potentially, it could be a spacecraft, from another civilization, or some technological gadget. Talking to CBS, he likens the situation to any of the Voyager spacecrafts launched by NASA. They will exit the solar system in 10,000 years. Just imagine them colliding with another planet far away a billion years from now. They would appear as a meteor of a composition moving faster than usual, Loeb explained. What's next? The research and analysis is just beginning, at Harvard. Loeb is trying to understand if the spherules are artificial, or natural. If they are natural, it will give the researchers insight into what materials may exist outside of our solar system. If it is artificial, the questions really begin. It will take us tens of thousands of years to exit our solar system with our current spacecraft to another star. This material spent that time arriving to us, but it's already here, Loeb said. In search of a big piece, we just need to check our backyard to see if we have packages from an interstellar Amazon that takes billions of years for the travel. He still has more debris to research and hours of unwatched footage from the camera attached to their sled. He believes there is a chance the spherules could be small breadcrumbs to a bigger find. They also help us pinpoint any big piece of the meteor we could find in a future expedition, Loeb said. We hope to find a big piece of this object that survived the impact, because then we can tell if it's a rock or technological gadget.